Welcome to an exploration of constructivism and how learners actively build knowledge. Over the next slides, we will unpack principles, strategies, and practical designs that make learning meaningful and transferable. Think of this as an overview that ties theory to classroom practice, highlighting how guided experiences and social interaction help learners construct robust understanding rather than memorize facts. The diagram here traces how learners assemble knowledge from raw sensation to coherent ideas. First, sensory data is selectively attended to. Then learners iteratively test hypotheses and reconcile new input with prior schemes, creating provisional, contextual meaning. Well-designed educational experiences then perturb and reorganize these structures, guiding students toward deeper, more integrated coherence. This flowchart explains how new information connects to existing schemata by first eliciting and revising learners' preconceptions through brainstorming and diagnostic tasks, surfacing misconceptions to create cognitive conflict, and then building conceptual networks for revision so that encoding becomes meaningful and knowledge endures beyond rote memorization. The graphic shows how dialogue refines meaning by exposing multiple perspectives through peer questioning, critique, and justification, which leads learners to articulate, reflect, and synthesize ideas together. Collaborative discourse becomes the mechanism for co-constructing shared understanding and evolving collective insights that are richer than any single viewpoint. Vygotsky's zone of proximal development illustrates how learners move from independent capability to future potential with calibrated support. A skilled partner offers scaffolding, models, prompts, and gradually withdraws assistance as strategies become internalized, enabling students to perform beyond what they could do alone and accelerating cognitive growth through guided apprenticeship. This slide anchors learning in real-world problems to infuse relevance and sustain inquiry cycles. Students might analyze environmental data sets to detect patterns, design market prototypes that meet consumer needs, or curate museum exhibits to tell historical or scientific stories, all of which mirror professional practices and promote transferable, contextualized knowledge. Multiple modes, text, video, simulation, and hands-on manipulation, converge here to create rich learning environments that support deep understanding and flexible knowledge structures. By translating ideas across symbol systems and highlighting different attributes, these representations accommodate diverse learning profiles and help learners form more robust, adaptable mental models. Structured reflection practices shown here turn tacit thought into explicit strategy. Scheduled reflection journals prompt learners to articulate approaches and monitor misconceptions. Gallery walks invite peer review and public articulation, and debrief protocols guide synthesis of key takeaways, together fostering metacognitive awareness and autonomous transfer to new situations. This contrast highlights critiques of pure discovery learning and makes the case for guided inquiry. Unguided exploration can overwhelm novices, increase cognitive load, and produce misconceptions, whereas structured, research-backed guidance, scaffolds, worked examples, and timely feedback helps learners focus, reach goals more efficiently, and achieve superior outcomes. This visual addresses social negotiation and equitable classrooms by naming the problem of dominant discourse styles and offering solutions. Explicitly teach discussion norms, value multilingual resources, and distribute authority so all voices co-shape knowledge. The aim is to legitimize diverse cognitive contributions and build shared, equitable understandings, rather than privileging a few. The digital extension slide shows how technology amplifies construction possibilities through coding platforms for interactive models, VR builders for immersive manipulation, and collaborative clouds for crowdsourced data and shared analysis. It also emphasizes critical literacies, like evaluating digital evidence and recognizing algorithmic bias as essential skills in a connected learning landscape. AI learning companions are framed here as collaborative partners that offer adaptive scaffolds, surface diverse perspectives, and embed ethical reasoning to support responsible judgment, while also helping cultivate communities that construct shared knowledge. The ideal is a balance between agency and guidance that promotes individual fulfillment and collective capacity to address global challenges.